Good morning, everyone. My name is Pam Bednar. I'm with Synchrono Manufacturing Software. I'm here to introduce our presenters. I've got Brian Andrus and John Maher. Brian is the IT Director of the newly formed Orbital ATK. Brian delivers and brokers all information technology services for the company and its Aerospace Structures Division, headquartered in Clearfield, Utah. Brian is a focused IT leader with a background in business operations and manufacturing. He's motivated by results and working with the end goal in mind, as you'll see in a moment. In his role, Brian develops the IT strategy and oversees initiatives that move the division towards its goals. And next to Brian is John Maher with Synchrono. John is responsible for providing strategic direction to the Synchrono demand-driven manufacturing platform. He oversees technology and delivers functions within the organization as well. He's been with Synchrono since the start of the company, has years of experience working with ERPs, MRPs, APS, supply chain, manufacturing planning and scheduling solutions, and more. John's experience helps drive continuous refinement of the lean and constraints management-based software and solutions that Synchrono delivers. So with that, I'm going to turn it over to Brian to get us started.
So the first question is, why do you want to listen to an IT guy, right? Here we are with operations and there's an IT guy up talking. So what do you want to hear from me for? Well, hopefully, after you've listened to my presentation, you'll figure out why. So a little bit about Orbital ATK. I come from the heritage ATK part of the business, and ATK used to have a recreational sporting part of our business. We spun that off to Vista Outdoors, and then we merged with Orbital, and we created Orbital ATK. So Orbital ATK is a private developer of space launch vehicles. We're the leading producer of solid rocket propulsion systems. We're a major player in missile defense. Currently, there's 98 satellites that we have in production, and over 800. We have content on over 800 satellites that are orbiting on orbit right now. We've also we're the largest provider of small and medium caliber ammunition to NATO countries. So you can see that we're an aerospace and defense contractor. And the company is made up of three different groups. The Space Systems Group, which is more of the satellites and launch systems. We have Defense Systems Group, which is our armament systems and our ammunition. And then our Flight Systems Group, which also includes Aerospace Structures, which is the division that I'm responsible for the IT on. So focusing in now on Aerospace Structures, we have three big business segments. Our launch segment, which is at the bottom there, has been our heritage experience. For a number of decades, we've been building structures for large rocket motors as well as other rocket motor cases. In our military segment, you can see that we do things for the F-22, F-35, and other military aircraft. And then our most recent addition to the business is our commercial world, which we've been doing for only 5 or 6 years, and we're going to focus a little bit more on that, how we came to get involved in the commercial part of our business. This part of our business has been one of the key focuses for all of the capital investment for our whole enterprise over the last 5 years. So I'm not expecting you to read this chart. If you want to look at it in the slides later, that's fine. But I wanted to point out a couple of things. So this kind of tells the story of our division and what makes us competitive. Back in the 1950s and 60s and 70s, during the Cold War era, we started building filament-wound rocket motor cases. And so that experience and expertise that we developed there moved us towards inventing an automated fiber placement. So carbon fiber placed on forms that are geometrically complex and allows us to do things like make wing shapes and other parts of aircraft. And so that automated fiber replacement machine helped us get contracts with Lockheed Martin for the F-35 program. And then in the early 2000s, we started working on an automated stiffener forming machine, which we have patents on, and it allowed us to enter into the commercial aerospace market, which is really exciting for us. So here's a quick view of what our content is on the F-35. You can see the wing skins and the cells. Down here at the bottom left is our fiber placement machine. You kind of see it's in action. So it multi-axis robotic device. So composites in aircraft manufacturing is what has really influenced our business. So if you can see across the bottom are the years since 1975, so last 40 years or so, you can see that the amount of carbon fiber composite content on an aircraft has not been very large, but around the turn of the century, new aircraft design started including much more of that. And that's obviously because of the weight ratio, and you can get 20% better fuel economy for those that are operating those aircraft. So A380, 787, and A350 are aircraft that are now in 787 and A350 are more than 50% carbon fiber composites as far as their structures are concerned. The Airbus A350, we were able to get all the stringers and lots of the frames for that contract. So if you'll notice, this diagram at the top left shows the different sections of the airplane, and so we build the longitudinal stringers for all of those sections, and then the frames which go around the barrel build for this aft portion of the aircraft. Interesting thing about Airbus is they have Tier 1 suppliers who we are supplying to, so we're a Tier 2 supplier, but there are different suppliers in different locations in Europe, also in the United States, and so they're all, even though they're all trying to meet the same production rate from a final assembly perspective, they're all kind of at a different rate in their own factories, and so we have to treat each one as separate customer, and they all have different requirements, and it becomes very complex for us to manage that production environment. So around 2010, after we got this contract, our legacy, our history, and our experience at Aerospace Structures Division was more low-rate, highly engineered products. And so we weren't really used to producing parts in a high-rate factory. And so that was a new change for us. And so we looked around and decided that we would take a 600,000 square foot warehouse that was near our other facilities in Clearfield, Utah, and that we would recommit that to a new factory. And so that was about the time that I became involved with this division. And they asked me to come in and talk to them about how we could put new systems in place, business systems, and connect factory systems and execution systems with the ERP system so that we could have a little better integration with our production environment. So this was our first major commercial program. Difficult to manage our schedules, and as we sold the program inside of our business, we had to bid that in a way that would be profitable. And so the way that we bid that meant that we were going to have to do some continuous improvement to even make our profit margin. So when we signed the contract, we didn't know what we were going to do, but we knew we had to do something. So when we talk about establishing a vision of what we're going to do from a factory perspective, of course we want to do all those good motherhood and apple pie kinds of things. We want to increase the visibility and efficiencies and managing our resources and being able to do continuous improvement and improve teamwork and decrease those things that we all want to decrease, costs mostly, shipping, maintenance, production. But what happened was you have all these different functions, supply chain, production control, procurement, engineering. Everyone's trying to solve these problems of how we're going to go from not having a factory to having a factory that's producing 12 aircraft worth of parts per month. And that was a big challenge. And everybody was trying to solve that problem kind of on their own. So production control was trying to figure out how they were going to schedule. Our contracts team was trying to figure out how they were going to manage all the orders that we were going to receive in different manners. Facilities was trying to figure out how we were physically going to put all this stuff in place. And my background before being in information technology was I spent a number of years as an industrial and a manufacturing engineer, and I used to think about how it would be great to have all of the information available that was being produced on the factory floor, just kind of as a byproduct of what was going on. You have machines there, you have operators collecting information, but all of the, years ago it was difficult to gather all that data together to help us make improvements. And so I used to think about that a lot, and that was 20 years ago. And so as we're getting together and listening to these different functional groups talk about the data that they need and where they're going to get it from, it became apparent that we needed to have an environment that was highly integrated so that we could share all that data together, and then people could use that in their systems, in their execution systems, or in their business systems. So as we, like I said, when we bid the program, we assumed that we were going to make improvements in order to meet our profit targets. But we needed to know exactly where those improvements were going to need to come from. And as we talked about this integrated platform that we might have in the future, we had our industrial engineering group go out and understand where our current systems and how we were using them today in our current low-rate factories, and kind of applied that to what our new higher-rate factory would look like. And you can see that red part of that graph shows what labor we'd have to add to our environment in order to do the work with using the systems that we had in place today on the high-rate factory. And so as that chart goes out, that's what the different rate increase. You can kind of see there's little edges to those. And every time we increase the rate, we go from 1 to 2, from 2 to 4. Right now we're at a 4 rate in that factory. But at the time, we were trying to figure out, well, at what point were we really going to be in trouble? And it looked like at about a 4 rate, which is where we're at today, we needed to have some new integrated system in place. So we started thinking about, well, we have all of these customers. What is demand-driven manufacturing, which is kind of a term that John is going to talk about in a little more detail. But as we study the problem and the complexities of all of the parts, because every part was unique, had its own tooling, multiple different tools for every part, multiple different processes for every part, we realized that keep in tight alignment with the demand that was coming from our suppliers, our customers. So a demand-driven approach provides that alignment by helping us synchronize the flow of materials. This little diagram here, it really shows pieces of the platform that we were starting to put together as we thought about this vision, and how we could connect to the demand coming in from our customers and our forecasts, how we could then, as we're producing parts, we could escalate problems and quickly turn around changes to the production schedule, so that if parts were scrapped in the middle of the day, we would know about that and we could substitute other parts in automatically. Also being able to have visibility to our machines and how they were functioning, and then have reports and analysis for not only the managers and the executives, but also for the operators on the floor, allow them to see how they were performing and how their work cell was performing. So I threw in a little slide here about IT and its impact on manufacturing. As I've studied manufacturing and I've studied IT and thought about the two together, I realize is that consumerization of IT, so more and more people have more IT around them all the time, more devices, that people start having apps to do everything, and they're driving IT within the business to deliver more things like they can have that are openly available to them. And so that creates more expectations on IT, especially when it comes to people thinking about how to improve the factory. They want to see, hey, what's my machine doing, and how is that compared with the humidity and the temperature from our environmental monitoring system, for example. How do those two compare, and is there some correlation there that we can make some inferences about? So that really, I think, is important for us to recognize, that as IT in general moves forward, and especially all of this Internet of Things and those kinds of technologies are going to hit us, I think there's some play there in the factory. So as we finally decided, hey, we got to have this integrated system, we had to bring together all of these functional silos together and try to understand, okay, this is your vision, but it's different from operations vision, and contracts, your vision is this, and supply chain, it's different. And so we spent a lot of time going through this iterative cycle of, we'd have consultants come and talk to us, then our functional leads would have visions and epiphanies, and we'd bring vendors in to tell us, what products they had to kind of solve these solutions, and then stakeholders would get changed, they changed jobs or something, and so then we have to repeat that cycle. And it took us months, quite frankly, to get down to a real solid set of requirements, which is what you're seeing right here. So we've talked about dynamic and pull-based scheduling, based on what our customers are ordering. Visual factory order boards and status boards. So that allows when the leadership team walks the factory and goes from work cell to work cell in the morning, they can see the status of that work cell, what its particular statistics are on, on-time delivery and quality and machine uptime, those sorts of things. Also, we needed to have the ability to have the machine itself tell us when there was a problem, not always wait for the operator to tell us, because sometimes the operators, they delay or they try to figure it out themselves, and we wanted to make sure that this escalation process would be automated and effective. A funny little story about escalation, as we started implementing that particular part of this platform, one of our analysts was working, and the way the escalation worked is it would go to the operator once the machine would say, hey, there's a problem here, then it would prompt the operator to say, what kind of a person do you need to solve this problem? And they could say, well, I need engineering or I need maintenance or whatever. And then a text and an email alert would go to that group of people. And if they didn't respond within 15 minutes, then it was sent to their boss. And so it went to our PeopleSoft system to figure out who worked for who and who worked for who, right, in the whole architecture. And as we were working out some of the bugs, one afternoon we found out that the CEO of the company had got 250 alerts that the machine on the factory floor was down, and he actually got a kick out of that. Problem was the GM didn't get a kick out of it, so we fixed that so that it wouldn't only go so high. But anyway, I remember one work center director coming to me, and when we were in the initial stages of talking about what this platform was going to be, and he says, I just need a visual factory. And I said, well, what do you mean by visual factory? He says, well, I just want TVs on all the walls. That's all I want. And I said, well, what are you going to put on the TVs? Well, I don't know yet, but I just want a visual factory. So it took us a while to drill down on all those concepts. Of course, one other point I want to make is the single operator interface, which is really important. So as historically, we'd have an MES system, an ERP system, time card system. We had all these different systems that were independent of one another, and the operator would have to interact with them, which would slow them down. And in a low-rate factory, probably not a big deal, but in a high-rate factory, you don't want the operator having to move around and do all those things. So we combined all of those in the background and gave them one portal, essentially, which we call the single operator interface. And that's really a key to what we're trying to accomplish. Overall equipment effectiveness, that's something that facilities and maintenance really is interested in. And then ability to promise, and when customers asking about, hey, where's my order, we can tell them, with confidence when they're going to get it. One other point I want to make here is that when you're putting in place an integration platform and integrating lots of applications, there's a lot of stuff that has to go on behind the scenes, and it costs money to do that. And people, particularly functional people, they want to see, what are you going to do for me? So what I call them was gold nuggets. You have to, in order to get them to buy into helping pay for the platform, you have to give them some gold nuggets so that they get something that they want, and they can show some improvement in their environment. This is I apologize, it's a lot of detail, but I already had this slide. I thought it would be interesting. This shows how our software application portfolio is integrated and how different systems interact with one another. So you can see that the top section, which is blue, is our enterprise service bus and all of the applications that are in our enterprise. And those are not applications that I host at my division. Those are things that are provided to me. But in the orange section are the applications that my team supports and hosts and develops some of them and purchases and installs on other cases. And that local service bus is really part of the Synchrono Sync Operations platform, which is another service bus which allows us to essentially plug in applications and then allow it to share contextual data to and from the historian, and then from the historian it can go to the other business applications. And as you look through there, you may notice some of those applications may be familiar to you. It covers the MES, gamut, quality, SPC, those sorts of things. The bottom section, key thing was being able to collect data and information tags off of those machines, and we had 13 different varieties of PLCs that we were trying to connect to. And that took us a long time to figure those out, because some of the machines, like I mentioned, we have invented some of our own machines, the automated stiffener, so we knew all about those machines. But some of the machines that we had purchased, we didn't really know that much about. And when we went to the engineers, they were a little clueless as far as, well, there's 3,600 tags of data that this machine produces as it's running. What do they mean? And they had no clue. And so it took us a long time to actually get to the bottom of that and be able to extract the right amount of data that was meaningful, and then publish that in context to the historian. So I want to talk a little bit about our project. So it took us a long time to develop the requirements and get a good set. And then we went out and talked to different suppliers and got estimates. We finally were ready to go and make a proposal to the president of the company. This was a large project, lots of capital, and he's trying to decide, how do I best spend my capital to get this factory up to where it's producing parts? Do I want to spend it on an IT system? And so we chose to do a phase gate approach, which allowed us to do incremental improvements, demonstrate that those were working, and put it in place, and then go back and say, so we've done this, now we're ready for the next phase. And you can see this is about an 18-month process where we went through and met with the president every 3 months or so and showed him what we've accomplished and what we needed to go forward and what we were producing. That approach actually worked pretty well. The first few reviews were difficult. In fact, it took multiple sessions and multiple meetings with the president to be able to explain to him what we were trying to accomplish, because we were not just implementing an ERP system. We weren't just implementing an MES system. We were implementing a platform which included all sorts of different things. So that took a little education and training as well. Well, one thing you'll notice, those that are familiar with ISA 95, that it has these layers that you kind of progress through as you are automating your factory. And scheduling the factory is like the third out of 4 levels, and our intent was to follow that path. Start with the machines and build the data, put it in a historian, and then start spreading the data out. We had one of the operations directors of this new factory, pound his fist on the table and say, as we get behind this, I can't wait for a year for you to help me schedule this factory. I got to have scheduling now. And so in order to get him on board, we went ahead and we put in place some scheduling functionality that we had to then replace later, but that was the only way we could get him on board. So it was interesting. But once we had him on board, he was our greatest supporter. So as I'm wrapping up here, what were the results and what have the results been? So 2010 to 2015, so it's been 5 years. We've had parts of the platform in place now for a couple of years, and we're still learning more about the machine data, quite frankly, and we're gathering more data. We're connected to all the machines. We just aren't sure all of the data that we're using yet and what we can use. But right now we're able to produce out of that factory now at a 4 rate. We're going to jump up to our next step in about 2 months to a 5.5 rate. And then in a couple of years we'll be at a 12 rate. So we're anxiously engaged in continuous improvement and trying to meet that profit margin that we set out with 5 years ago. Also, the one note, we moved some of that technology and most of that technology to other programs and other factories. So now the Joint Strike Fighter, which was already in place and already functioning, we've actually gone and retrofit this system into that. Well, about a year ago, we were able to get some of the content on the Boeing 787, and so we're standing up a new work cell for that, work area for that, and this is completely part of that work cell. So it's a great example. One last thing here is if you're thinking about going after a kind of a large platform, kind of a project, some of my thoughts would be make sure that you align with the leaders' visions of the functions, because you got different people with different ideas, and sometimes they're not congruent. So make sure you understand that and spend the time with them so that you can establish and capture the real vision. And then keep them aligned and involved. Ensure that everybody gets a gold nugget, right? Everybody needs to have something that they're getting out of this system if you're going to go and spend this much money and spend this much time. Being sensitive to turf, I didn't really drill down on this too much, but engineers think that they own some of this, and that they do own it, but they tend to think about their own little work cell or their own little process. They don't tend to think about this as a broad process and a broad platform that they could reapply across all of not only their factory, but also other factories in our business. So my point was, with the engineers is they had their own things, right? They were trying to meet this challenge of meeting this rate. And so we had to kind of get with them and include what they were trying to accomplish into the vision, which really helped. In fact, we had a lot of conflict at the beginning, and after we came together, then they were our best friends, and we worked together very well after that. So, of course, the phase gate, as far as managing a project, I think works well. Certainly, you want to, we've talked to a lot of different suppliers, a lot of vendors of this kinds of technology, and this platform that we've put together, is not just one provider, but a major provider is Synchrono. So I'm going to let John Maher now kind of address some of the specifics about the implementation of how we put this together.
Thanks, Brian. So, working with Orbital ATK it's been a fun project that we've been working on. It's an exciting opportunity when you get to go into an organization that's going from a 1 rate and working their way towards doing 12 times as much as they're doing from day one when you implement to where they want to hit from the finish line. And as a software provider, it's really, from a software perspective, you have a cluster of capabilities and functions. It's only really when you go out and are implementing and working with partners like Orbital ATK that you can actually move it to the point where you say, I have a solution, right? I can drive results and give the customers what they're looking for and need. I'm going to talk from the perspective of just a bit more about demand-driven and the demand-driven approach, but also about technology's role in it and why technology is important in a demand-driven journey. So a few items that are critical for technology to be in play for is technology is really the only way that you can have an enterprise view of the organization. If you have spreadsheets and whiteboards and different pieces of information, really those only stay within that local area, right? And that can't be leveraged, and nobody really has that view from end to end within the organization to where they can make global views. It's only really with technology where you can kind of unleash or liberate that data so that everyone can be working off of that same data and know how the decisions that they make locally are impacting the organization as a whole. Real-time only exists in the digital realm. One of the things about whiteboards or printed things is that the moment you print them out or write them down, every moment that goes by after that, they start to become obsolete, right? So as time ticks by, they become less and less relevant. Really, with technology, you can have real-time information so that I can know exactly what's going on and have the data there for me at the time that I need it to make the most appropriate decision to improve my organization. Seems like kind of an oxymoron, but demand-driven decisions cannot exist without data, right? If you like shooting from the hip and working off intuition, that's fine. But, really to get understanding how to take your organization forward, you need the data to kind of take the emotion out of it and tie you to what's really going to drive your organization forward in the future. And really that data collection needs to be just part of the normal process. And it can't be a cumbersome thing that no one really understands how it relates to how the organization's doing. Otherwise, you'll never get good data out of it. One version of the truth, it kind of ties back to the enterprise-wide view, but having everyone working off the same information is critical to the organization to understand and how to impact the business, I guess, from a global level. So, often when we walk into environments, and Orbital ATK was not the exception here, you have these pockets of information where different engineers are keeping their own spreadsheets and different production people are keeping their own notes, and they vary from one another, and everyone's kind of keeping score on their own little scoring sheet, and nobody's really kind of controlling that global view of how things are supposed to be getting done. And then the last point for why technology is that, when it comes down to it, manual is wasteful. If you're into lean manufacturing, there's the whole creativity before capital concept, right? But at some point, if you're maintaining whiteboards or if you're doing things manually, it becomes wasteful. A good example of this, I went into a heavy lean manufacturing organization, and they were doing manual hijunka, and they basically had 8 people, 4 people working 2 shifts each, manually working this hijunka cube, right? And sure, they weren't spending the money on technology, but you take those 8 people, you multiply out their salaries, and at some point you can take a look at, people don't often think about, like, with manual, with whiteboards, with Excel spreadsheets, what's really my total cost of ownership, and how am I impacting my environment by continuing to do this? A key thing with the platform that we implemented, Orbital ATK, is, to me, it's the concept of single thread of data supporting multiple levels within the organization and multiple levels of decision making. So taking it at the lowest level at machines, and basically the information coming off those machines, being able to leverage that information to understand, one, at the process engineer level, how I improve that machine, but also being able to take that up to the maintenance and facilities people so that they're getting their OEE numbers. Take it up to your Gemba walk so that as you walk around the floor, you know how different work cells in the organization are doing, and rolling that up to ultimately the factory and understanding how the factory is doing off of that same data. Again, when we went to Orbital ATK, you had different machines that were collecting local data, you had different spreadsheets, you have different things, and to me it's really, again, the liberation of the data so that the entire enterprise has it at their disposal, and so that everyone's working off of the same data and the same information. At its core, there's interesting and cool-looking pieces of technology that allow you to have your alerts and have your KPIs available to you. But at the core, the key principles have to be things that drive the performance of the organization forward. And for Synchrono and for Orbital ATK, that was really around driving around the core tenets of a demand-driven organization and driving demand-driven flow. And the core pieces of that is controlling the release. I'll talk about these more in a moment, but controlling the release into the environment or creating pull, synchronization of activities, aligning your continuous improvement, extending it to the supply chain, and aligning metrics. So controlling the release or creating pull, it's all about controlling what I'm gating into my system to be at the rate that the system can handle it. Any more work in the system than the system can handle just really creates traffic jams within the environment. It's not really helping you to get to that end goal of delivering to your customer. It's just getting in the way of the parts that you actually need to flow through the environment from them getting through the system. Early on when I started getting into pull environments, the first time I implemented pull systems, it was really like turning on the lights for me, because if you're in a push environment where everything's getting launched into the system without regard to what the system can handle, it's very difficult to see where your true capabilities are, where your true issues are, right? And this is where just-in-time was kind of a concept back then. And most people got it wrong in that they thought just-in-time was just get rid of all inventory and everything will be perfect, right? But really, what just-in-time was trying to teach people was, incrementally take it down, and with every level of inventory that I reduce, I get a clearer view of my operations and what's obstructing me from getting down to that next level, and then eliminating those and then take it down to that next level. So within the demand-driven manufacturing platform, we use a patented scheduling logic called CONLOAD, which stands for consistent or constant load, in which we look at pacemakers or leverage points within the environment, and everything that gets released into the system is gated in based off what the system is actually doing and how the system is performing, so that we keep that nice level amount of work in process. Second one is synchronization of activities. So we focus heavily on optimizing the flow through the entire organization, not just local efficiencies. Again, if I go back to my technology slide, why it matters, it's this whole global view of what's important for the organization, right? And you can't think that like doing what's best for me is the best for the organization when you look at local efficiencies, because you go into any environment that has assembly points or convergence points, whether it be at assembly or at shipping, and you go down their list of things that they need to complete off, and each item on the list is missing that one golden screw that if they had it, they could put it out the door. And the reason for that is because it wasn't the most efficient thing at the beginning of the process for the lathe operator to run, or it wasn't the most efficient thing for welding to run. And what ends up happening is your flow gets disrupted, and your throughput and your overall service to your customer gets disrupted. So part of that technology is about synchronization to make sure that the upstream operations are working on what the downstream operations need, so ultimately it can come together and deliver to my customer. Within our solutions, we focus on synchronization of labor, material, machine, and method. Just to give you a quick example on this fuzzy screen that you can't really see from back there, this is a work-to list out on the shop floor, so we have clear indication of the level of priority. Red, yellow, green shows us, where we're at. But a key item that I just wanted to focus on here is on the left-hand side, we have these things called chevrons. And what the chevrons indicate is to the operator that everything's available for them to do the work. There's no false starts, right? And this was a challenge at Orbital ATK when we went in. They were trying to do little matrices and stuff like that to make sure that they had everything. But they needed to make sure that they had all the materials. They needed to make sure that the tooling was available. They needed to make sure that they had a quality plan established for the part. They needed to make sure that they had the machine programs, all of these things, right? So part of the process was integrating with the PLM solution, integrating with the ERP system, so that the operator knew when everything was available and in alignment, so that they knew if that was the next thing that they worked, that they wouldn't have to stop, that they'd be able to work it through completion. And the additional advantage of that was that the supervisors, or the people responsible for the work cells, basically the operators shifted from having to worry about all these things that they needed to just being able to focus on the things with the chevrons. And their support people were the ones looking at the things without chevrons to make sure that they got everything that the operator needed. And you can tie this back to engineering, and the engineers actually use the information coming out of it to prioritize what they're doing to be in support of what overall operations needs. Continuous improvement based upon flow. So, these are just some questions to ask within your own organization, but how do you direct your continuous improvement efforts? Where's the area of the organization that I should go into and focus my next effort to get the most advantage for the organization? And how do you avoid getting those wins but stalling out or stagnating at the next level of performance? To me, it all comes down to flow, and really the understanding of where to direct my continuous improvement efforts really has to be with that global view in mind again, all right? And for me, that's tied to flow. So within the demand-driven platform, basically it's about understanding where your disruptions to flow happen, right? I mean, the fact that a machine takes a long time to set up, right? You can do your continuous improvement effort and you can say, I'm saving the company whatever number you want to pick, $200,000 a year because I cut the setup time in half. But if that machine wasn't what was disrupting flow, that ultimately means that I'm not going to get any more parts out the door, which ultimately means that I'm not going to do anything to my financials or to my bottom line, right? It's only when you understand it and ground it in flow that you can really understand that if I go to that area and I do this continuous improvement effort, I might get the biggest impact to flow and the biggest impact for my organization. Just an example of a board that they use at ATK, one of the things that we're doing is collecting, downtime by reason code on the machine. So at the point that, we Pareto it out and we say this particular machine is a problem, the data of the platform is building so that when it's time to focus our CI lens on there and improve it, that the data to support and make the decisions of how to best improve it is available to me. Extending it out to the supply chain, one of the things that we like to talk about is synchronization from the factory out, get your house in order and then extend it to the supply chain so that we're not constantly moving signals around to our suppliers. And really it comes down to giving the supply chain visibility into your operation and into what your needs are, right? Having a bunch of due dates that you don't even know if they still align with what your plant actually needs and constantly calling and pestering your suppliers about whether or not they're going to hit those needs is an approach, but I think that a more effective approach is having them understand really what your needs are and having that visibility into the parts that they supply and the urgency of the needs for that so that we can put an end to the constant phone calls and emails that occur. And then finally, aligning metric. One of the things that the late Ellie Goldratt liked to say was, tell me how you will measure me and I will tell you how I will behave, right? So you can't have metrics that are out of alignment with what your overall organization goals are. You can't have things that are supporting local efficiencies if you're trying to get global flow through the system. And, ultimately it puts your people in a bad position if you're telling them to do something, but by them doing it leads to them getting chewed out at all of their reviews for what a terrible job they're doing because their metrics aren't aligned with what you're trying to do. And really what we're trying to get is to where there's a positive reinforcing loop so that people understand what they're doing and how it supports the overall organization, and that by them doing that, they get positive feedback and want to continue doing it. So that concludes our presentation for today. If you want more information, there's certainly our website, synchrono.com.
Thank you for watching. This presentation was recorded in 2015 at the Industry Week's Best Plants Conference. A case study outlining Orbital ATK's demand-driven transformation is available at synchrono.com, along with a wealth of other resources. For more information, please visit synchrono.com.